Thanks for joining us today. My name's Zach Allison with ATS, and we're going to dive into our next of a long line of product seminars called our ATS University. As a reminder, you may have just heard, but we are recording the session so that we can host it on our ATS University section on the spec tool, where you can review all the previous presentations, request additional, maybe firm-specific versions of those presentations, and also review some of the code-related or sizing-related aspects to the products that we cover. As with a variety of these online webinars, everyone's muted upon entry except for our wonderful panelists today, although I will be keeping an eye on the chat and QA field. So as we go through the hygienic hydration topic today, if you have any questions, feel free to pop in there. I'll bring it up to our panelists, Mitch Whittington from Murdock and Rob McLeod from the Dobbin sales team. Dobbin sales being the distributor and rep for the Murdock product line in Canada. We do have a number of folks from both sides of the border today, and I believe this is an AIA accredited presentation as well. So if you need your AIA information after the fact, please let us know and we'll get that sent out to you. For all of our Ontario listeners that are trying to get all their CPD hours together, we were able to get our automatic certificates sent out for the previous presentations, and that process is working smoothly now. So all the attendees get your certificate of attendance afterwards, and we'll also send those out for our Western Canada and Eastern Canada attendees, as I know there are additional similar programs to the PEAK program for our engineers. So without any further ado, I'll let you dive in. Mitch, thanks for joining us today, and we're looking forward to the past, present, and future of hydration.
Absolutely. Thank you, Zach, and thank you, everybody, for taking some time and attending with us this afternoon. As Zach introduced me, again, my name is Mitch Whittington. I work for Murdock Manufacturing. So we've been a water cooler and drinking fountain, as well as a fire hydrant and water hydrant manufacturer since 1853. So been around 170 years, where we do have specialized in the space of outdoor drinking water as well as indoor drinking water and bottle fillers. So today, let me go ahead and pull up my presentation here. Should I share my screen, Zach? That worked good for everybody?
Yeah, down the bottom middle, you'll have the share screen.
There we go. Let's see here.
Looking good.
Everybody see that? Slides are changing properly for me?
Yeah, looking good, I think.
All right, perfect. So we're a company based out of California, been around since 1853. So we'll go ahead and dive right into it. So are the slides changing right there for me? Just want to make sure. All right, perfect. I'm in the presenter mode, so I just want to make sure everything forward facing looking good. So again, just to kind of go over the purpose and the learning objectives, kind of for our presentation today. So really our goal here is for the purposes that contemporary drinking fountains, water coolers, bottle filling stations really do provide the community with access to safe and clean drinking water all over their cities and their school districts. So this course kind of goes through the history of the drinking fountains, what kind of regulations surround some of the distribution and treatment things that have changed over the years, as well as kind of introduces the trend in touchless activation due to the COVID pandemic and other concerns, as well as we're going to compare the use of bottle fillers and bottle filling refill stations compared to the water bottle industry as a whole. And then of course for the specifiers, we got to have, to go through those guidelines and those specifying things that we're going to look at for commercial water delivery in terms of your projects. So my goal for you guys at the end of this program, that you guys will be able to, kind of summarize the evolution of drinking fountains, the changes in the public attitude towards them, which has definitely shifted up and down over the years with bottled water and other sorts of contaminants and concerns, outline those standards that are applicable to them for your specifications, understand those environmental impacts of plastic bottles and looking as bottle fillers as a sustainable alternative. And then finally, just specifying water delivery solutions appropriate for your environment and your projects that you guys are specifically working on. Just going to go ahead and breeze over some of the certifications and things like that and just dive right in. So a little idea for your table of contents. My goal for you guys is to keep this to 40 minutes. I don't need to keep you guys here for an hour and a half and dive way into your lunch. But we're going to start with the history of drinking fountains, and then we're going to kind of go to the history of water distribution and treatment, and then the standards and compliance that go along with it, and then take the deep dive into the specification and comparison to the bottled water industry as well. So just a nice little quote. So water is essential to life, and safe drinking water is acknowledged as a basic human right in the industrialized nations in our world. Drinking water quality guidelines and regulations are set in place to ensure that the public has access to clean, safe drinking water throughout a variety of water delivery solutions. So we're going to dive into drinking fountains as well as some of the standards that just go around anything that's intended for human consumption, whether that's through drinking, cooking, or any other types of consumption for that water. So a little bit of the history of the drinking fountain. Between aquifers and, other means of transportation, water delivery has always been a main challenge for us, as we've kind of produced and become a larger community. So fountains can be traced all the way back to the ancient Greek cities. But back then it was basically just a bubbler with a nice, convenient, responsible option for others. But most of them just had, something like a cup and a chain attached to it for community use. Something that you'd see there on the right, which was really the original public drinking fountain. Started in London in about the 1850s, and then quickly went over to the New York Times, where New York City was the one to follow them almost, just a couple of months after. Even was used as, interesting enough, as some advocate groups used them to discourage the use of readily available alcohol at the time, which was almost more frequently available than water in some of the major cities across the country. So around the earliest 20th century brought along things like the bubbler, which originally started as that picture you'll see on the top right, just enough pressure to create that jet stream. I was just in Portland a couple of months ago and actually saw one just like this that's still up and functional. That was really along with the realization that the common use cup from everybody in the city was not exactly the most sanitary option, and people could yet still continue to put their lips over it. And thus came the things like the mouth guard and the angled spouts to kind of create a discouraging moment to people all trying to share that bacteria and those germs. Really around the 1970s and 1980s was when, really the bottled water industry became to a massive surge around the concern of lead poisoning around the original way that these fountains and construction, kind of were created back around the early 1800s, that it's still been sitting around. And that's where the main surge of bottled water became popular. Realistically, more than 80% of those early issues in the US were caused by systematic problems within the drinking water system, not exactly by the fixtures that they were used to provide water. Given that this was still, early 1970s when these studies were done, you still had, a lot of the higher lead content and things like that allowed in our plumbing fixtures, which we'll go over a little bit later. And obviously, since then, we've had a ton of written code around things like lead contents, contamination reduction, minimum and maximum operating pressure to ensure that you're not having any standing stagnant water, and all of those things that really, ensure that they're mitigating a lot of those types of risks, especially things like using copper tubing waterways and other antimicrobial materials within the product. So kind of restoring some of that public trust. Manufacturers, even before, around the 2011 lead mandates for the 0.25 weighted average, had started to remove lead parts and replace those lead parts from their fountains, and started to follow more of the federal lead-free requirements, usually even more stringent than they had been written. A few ways that those manufacturers can mitigate those risks of drinking fountains and really start to regain that public interest and that public trust are listed here. So again, you're monitoring and you're testing of all of your water fountains in public, and a lot of the municipalities do this on a regular basis. A lot of the school districts, whether it's the sustainability committee or their facilities managers, make sure that they're always testing these things on a regular basis. Of course, developing and making sure you're using those standard protocols for maintenance, repair, replacement, changing out those filters within its lifespan, changing out those valves when they're leaking and things like that. And of course, replacing your legacy and your older plumbing systems with more modern systems, not running things through galvanized pipe, making sure that these are plumbed in the most up-to-date and modern ways. Updating your types and your function of your old drinking fountains. Eventually, sometimes it is just to upgrade those old fountains that are incredibly old to something more modern, something more up to standard code today, something like you'd see in the image there on the right, as opposed to something that's, been around since the 1820s. And then, of course, we've just greatly increased the number of fountains. They're a lot more publicly accessible, and of course, being able to show that communication to the public around the sustainability and cleanliness of these fountains has been huge. So we'll kind of dive into the next portion of the presentation, which is water distribution and your treatment. So just a little brief history of, kind of the way that water's been, dug around and treated all the way since, the 3100 BC, where people were just digging wells and throwing, things like palm leaves over it to protect it from the water, all the way up to, using things like aqueducts, providing gravity flow in the Romans, and, moving all the way up to when Boston was using logs, which are bored out, which are, even actually still underground in some locations there. Cast iron pipes became a big thing in the 1800s, and then all the way moving up to the the American Water Works Association in the 1880s, which, just kind of absolutely changed everything. So, it does date back, going back about 6,000 years for water treatment. Where ancient texts discovered the addresses of boiling, being able to expose your water to sunlight, filtering it through charcoal, sheepskin, all sorts of things that really just, for them at the time, just addressed the cloudiness of the water and started to, use those things that pulled that type of stuff out. And then in about the 1800s, when a lot of our settlers in our country were moving across the country, that's when a lot of the sources and effects of drinking water contaminants were, kind of identified. Things like pathogens and microbes going through untreated water and being distributed into, the waterways, creating massive amounts of things like cholera, typhoid fever, etc. Probably one of the biggest examples would be Dr. John Snow, which is probably the largest breakthrough in water treatment to date. I'd love to see, anything probably larger than this as a realization, where he was actually able to track a cholera outbreak in London in the 1850s back to a common well that had been contaminated with sewage. One of the number one ways that we figured out that, our drinking water was one of the things that were making some of the largest illness across our countries really take effect. Around the 1880s, that's when Robert Koch showed you kind of some of the microbial effects of, hyperchlorates and things like chlorine in terms of mitigating risk in the public waterways, and really started to contribute to that transformation of water treatment. In 1908, New Jersey became the first city in the U.S. to actually use the chlorination process on its public water. And then over time, cities all over the U.S. started to do that and still use it today. Over the next few decades, they saw a massive reduction in things like typhoid fever. Like I said, chlorine still used in a lot of water treatment and drinking water facilities today, sewage and wastewater as well, reservoirs, all sorts of ways to, kind of disinfect, get rid of the algae, get rid of a lot of those harmful microbes that we really don't want to be put into any type of potable water. So some of the drinking water standards, a lot of the original regulations around drinking water really only pertain to contaminants that could cause contagious diseases, and really only pertain to water supplies that were on a lot of our international modes of transportation. So since there was really no required compliance, a lot of states just adopted the PHS standards, which after a lot of revisions around the 1962 was adopted by every single state. And at the time, the need for additional oversight became apparent, and that's really what created the EPA in the 1970s. So for that way, the EPA kind of gave it as an independent agency, kind of gave those checks and balances, and giving that need for federal enforcement authority to oversee things like drinking water, but also your air pollution, your solids waste programs. Obviously, the EPA is still a massive influencer today, and led to a ton of improvements in water quality standards, to a ton of legislation, including the Safe Drinking Water Act. Some of the NSF certifications, have around water and water filtration have kind of driven from a lot of these types of acts across the North Americas. So a lot of your freshwater sources, just approximately 80% of the drinking water in North America is coming through your sources through surface water, and not a lot of that is coming through any of your underground or groundwater aquifers. So there is an estimated 155,000 public drinking water systems across the country that are all regulated, and most people in the Americas, in the North and South America, even receive their drinking water from one of the about 50,000 community water systems. So distribution, I'm sure many of you guys are familiar, kind of with this type of process, with your source to your treatment plant, to your storage tanks, and then off to the mainline distribution before being returned to be clean. Obviously, your water supply is going to be regulated by your federal and state governments. Health and those environmental regulations are governed at the state level through the EPA, but in terms of your bottled water and your drinking, that's going to be going through the FDA, which we'll talk about here in a little bit later. So what's naturally in the water? Really, the most common dissolved substances are just going to be your traditional minerals and salts that you would see on, your periodic table, your calcium, sodiums, your bicarbonates and chlorides, and of course, some of your nitrogen and phosphorus, and some of those things that are from your organic materials that are around our waterways. So common steps used by those community water systems. So you've got your coagulation and fluctuation, where chemicals with a positive charge are added to that water to neutralize the negative charge of that dirt and other dissolved particles. This is also commonly used in things like grease traps to get that grease to separate from that water so it can be skimmed and separated, usually on the first stage of that. And then your sedimentation, which just settles down into the bottom of the water supply due to its weight. So your heavy sands, rocks, things like that. And then, of course, once that is settled, your clear water passes through an actual filter of composition, whether that's sand, gravel, activated charcoal, all of different pore sizes to remove those dissolved particles, all the way down to dust, parasites, depending on the actual size and micron that's able to filter down to. And then, of course, your disinfectant, your chlorines, your chloramines, which may be added in order to kill any of the remaining parasites left after all of the treatment has been done. And then, of course, there's filtration out there afterwards at the point of use in the water cooler industry, which will remove that chlorine back out of the system through your chlorine taste and odor certifications through NSF. So a few things that the EPA has established. They have established primary and secondary drinking water regulations. Really, the main ones that we need to focus on are those primaries. So those are those set mandatory water quality standards for drinking water contaminants. They are enforceable standards that set maximum contaminant levels, and they are there to protect the public against any of those contaminants that present a risk to human health, whether that's lead, chlorine, any of those other contaminants that can be found prevalent in water that can lead to health effects. Some of the main things that they are looking for limiting those levels is your microorganisms, any type of disinfectant, disinfection byproducts, any inorganic, organic chemicals, and any radionuclides for any radiation concern on those types of things. So under the Clean Water Act, the EPA has implemented pollution control programs, such as setting wastewater standards for industry waterways, just to ensure that we speed up that natural process by which water is purifying itself. That way we can use our rivers and streams for things like boating and swimming and drinking water, and we don't have a lot of polluted waterways that we can't actually enjoy on a day-to-day basis. And that's very much what that Clean Water Act is set around for the EPA. So just a couple different types of sewer systems. So originally you had those combined sewer systems collecting your water runoff, as well as all of the sewage and wastewater coming from the buildings and homes around that area, discharging it directly into the waterways. But the biggest issue that you can see there on the right was as extreme wet weather events, you'd get the confined sewage overflow, which would fall out into our waterways, potentially contaminating those waterways and preventing posing a risk for public health in the environment as well. Today, we give a lot more sanitary sewer systems. About half of the U.S. population has access to something like this, and as these older systems are getting dug up and replaced, this is what they're going to. So the carry from that wastewater, whether it's domestic, industrial, commercial, is all going directly into that wastewater facility, ensuring that you're not having that massive outfall into our rivers and waterways. All right, we'll dig into some of the more standards and compliance here on our actual, kind of drinking fountains and water products after we've gotten through the little bit of a wordy history there. So I'll go ahead and take a quick break. If anybody has any questions, Zach, anything in the chat or anything from there, if anybody would like to
speak up yet, but I want to check in with Rob real quick. Is there any specific differences in Canada that you see for the sanitary system that he was talking about there?
Thanks, Zach. Yeah, there definitely will be our own set of codes and standards that are going to be applicable to our different provincial governing bodies here. So a lot of those I do find kind of will mirror a lot of the codes and standards that Mitch is going to talk to here, just with some little tweaks from, obviously not with the sanitary stuff, but it's speaking about, rough and height requirements for barrier-free compliance, certain allowable lead content and other things that we are testing against here and measuring against. So slight little different tweaks. Obviously, anyone could feel free to reach out to myself or reach out to the ATS spec team, and we'll be able to help you kind of drill down to where your specific project is from a local code standpoint and be able to help steer you in the right direction. If you ever have any clarification you require or need any help, please don't hesitate to reach out. I'll throw my contact information into the chat here, Zach. So if anyone has anything that they want to mention offline, please feel free to reach out.
Perfect. Yeah, and if any other questions come up, we'll be sending a link to where this webinar is hosted to everyone in attendance. So if you have any additional questions, you can reply back to that, and we'll be sure to follow up with those specific ones.
Perfect. Well, I'll just go ahead and keep on moving. So we're going to talk about some of the standards and compliance around drinking fountains, water coolers, and bottle fillers. First, and probably one of the most prevalent, would be your ADA standards. Became law in 1990 for the American with Disability Act. Obviously, you guys are going to have something very similar for your Canadian access. Rob, is that correct?
Sorry. Yes, that's correct. Yeah, we have. Obviously, there's within the National Plumbing Code, but then you're going to find with each specific province has their own little variants of it. So we find, everything typically that is ADA compliant will work here, but there's going to be slight differences in the rough in height, like maybe where the bubbler height requirement is maybe a little bit different. So, Zach's team will do renderings to actually produce a mock-up to show you what is a OBC compliant rough in height and whatnot. So there's lots of little tweaks, but we'll mirror this fairly closely.
Absolutely. And with us and with many of the manufacturers in the industry, everybody's going to be able to generate these ADA compliances. Anything that you guys need in major, modifications or anything like that, please just come to your manufacturer. We're always more than happy to make those minor adjustments, as we are very familiar with the variety of codes across North America. So we'll just go through some of the 2010 codes, as I know a lot of these are very similar. So, over drinking fountains in general, many people do apply to the 211 minimum number, which no fewer than 2 drinking fountains shall be provided. That has definitely increased the popularity of the bi-level unit that you'll see there on the right. Many manufacturers have this unit available to be what we call versatile. So whether you want the right side to be the low side, the left side to be the high, or vice versa, the same exact product is able to be modified in the field to be able to do that. The main compliance here is that in the image here on the right, your unit on the right would be ADA compliant for somebody constrained to a wheelchair height, through your toe clearance, knee clearance, and bubbler height, which I'll show you here in a second, as well as somebody who has a problem with their back or something other kind of issue, which prevents them from bending over to the lower unit, which is the concept there behind the dual unit. So if we're more than the minimum number of drinking fountains specified are provided, 50% of the total number of drinking fountains shall comply with 602 and 602.6, which we'll talk about here in just a couple of slides, not just leaving you hanging there. And 50% of the drinking fountains should comply to 602, which is just going to be your clear floor space that they both have to use, as well as your spout height and your spout location. One of your most important things here is going to be your spout outlet should be 36 inches maximum above the finished floor and ground. Keep in mind that is from where the water comes out of the bubbler itself, not from the top of the basin of the designed unit. All of the manufacturers in the industry are aware of this, so you really shouldn't have any concerns there. as well as your spout location needs to be a minimum of 15 inches from the vertical support that the unit is mounted on, as well as 5 inches maximum from the front edge of the unit. And that includes any other bumpers, push buttons, or anything like that. Your water flow, so your spout shall provide a flow of at least 4 inches high minimum, and shall be located, again, 5 inches maximum from the front of the unit. Almost every single manufacturer does have an adjustable regulator within their product. We understand that every building does have a generally different, baseline pressure. So most bubblers are able to be adjusted in field to get that exact stream height when you're doing that inspection. Given that the product does have the proper PSI coming into it as its minimum operating pressure, which is usually around 40 PSI depending on the manufacturer. In addition, the angle of the water stream does have to be measured horizontally relative to the face of the unit, where the spout is located less than 3 inches from the front of the unit. The angle of the water needs to be at least 30 degrees. Spouts between 3 inches and 5 inches maximum from the front of the unit, basically just ensuring that that stream does set far enough above the unit where someone can consume that water without having to either, set their chin on it or have to stand up out of their chair. Again, this is something that's always able to be adjusted in field based on pressure, so not very much a huge concern. For the drinking fountains for standing persons, as you see here, kind of in the image on the right, they've got 2 down at the chair height, ADA height, and 1 for the standing person only ADA height. Those spouts actually for standing persons can be 38 inches minimum and 43 inches maximum from the floor and ground finish. And again, on your bi-level units, that higher unit will fit into that compliance. So the Safe Water Drinking Act, or the SDWA, is really to protect the drinking water and its sources. Under its administration by the APA, almost 100% of the communities in the U.S. and North America have drinking water that meets these federal standards. Obviously, the standards are going to be different up in Canada, but they are very similar written in legislation. Really, the only requirement around the drinking fountain and water cooler manufacturer world that needs to really comply with this is to prevent any lead from drinking and leaching from our products into the drinking water. So it really does prevent any use of any pipe or plumbing fixtures. So any of the solder fittings or any of the flux that we use, basically, or anything that we're going to be using in a repair for either residential or non-residential, providing that for human consumption, that it is lead-free entirely, and that we do comply to that. Almost every single cooler company in the industry is going to be able to comply to that. Obviously, there has been some negative light around the cooler industry on some of these things, not because of our fault, but you get to things like Flint, Michigan. The news camera comes down, points the camera right at one of the coolers, but that's not really where the lead contamination is coming from. It's coming from the dated piping systems behind the wall, the lack of filtration coming into the building, and lack of treatment in the general area itself. All of our products are going to be certified by some of the certifications we'll talk about here in a little bit, to be compliant, that anything that is not going to either leach from our product or have any lead within the product. And this became very prevalent even around the fittings used with our products in the 2011 Reduction of Lead in Drinking Water Act, which mandated that any wetted surface contact with water be less than 0.25 weighted average of lead. So that included everything within our product, as well as the fittings on the inlet supply coming into that unit as well.
And that Lead-Free Act has gone, across the country, nationwide, as well as internationally with Canada now as well.
Yep, absolutely. And I remember I think I was about 16 when that hit in 2011, and I was working in a plumbing manufacturer, or a plumbing distributor. I remember throwing away hundreds of old brass valves that didn't comply by the January date. And so it's nice to be able to see those types of things. So for your NSF and ANSI standards, there are about 8 accredited third-party certification bodies that provide certifications basically to the Safe Water Drinking Act, lead-free requirements, as well as NSF International and UL are probably the most recognizable testing organizations, at least in the US. The 2 main NSF certifications around the physical product, not just the filtration, but the product itself, would be NSF ANSI 372. which dictates that the product has been certified as meeting the weighted average lead content of 0.25 when used in respect to wetted surfaces, pipes, fittings, fixtures, etc., which is what we just talked about there. And then your NSF and ANSI 61, which dictates that the product's been certified to meet leach-it requirements for contaminants inside that product to ensure that none of those things are leaching into the product. NSF and ANSI 61 has been adopted by both IPC and UPC, and the NSF 61 will meet the requirements for the Safe Water Drinking Act. UL and UPC, so all plumbing is certified to the UPC standards for both Canada and the US. Your lead content verification of these products, is it just products in contact with any types of potable water? So this covers any drinking water systems, so any water cooler, any bottle filler, but this also includes anything that dispenses water intended for human consumption by drinking or cooking. So even your faucets in the kitchen and things like that are all going to be under this type of certification. For your IAPMO, so I'll just breeze right through this. So the green UPC logo is a registered trademark of IAPMO. Basically, products with that green logo meet the standards for green building and water efficiency. So just make sure you're looking for that on our products, but not just ours, but everybody else. Realistically, really the only current green standard for water coolers, bottle fillers, drinking fountains in the entire industry is a minor flow reduction in the bubbler just to reduce that wastewater. A study was done that usually when someone uses one of these products, about 60% of the water isn't even getting into their body and drank. It's going right back down the drain. So reducing that flow rate while still being able to provide that 4-inch stream is really the main way to receive a green or green cooler certification as of today. None of the condensers, compressors, or the refrigeration loop use enough energy to even be Energy Star green certified. So really that's the main standard around water coolers right now. It's just the flow rate. All right, so we'll talk about some bottled water versus kind of our bottled water refilling stations. So bottled water has been lately losing its reputation as that easier, more convenient, superior choice to whether it be tap water or public drinking water. Largely around a lot of the journalism and other things that have shown that most of the bottled water industry is just simply using purified municipal water. They're reverse osmosing, pulling everything out, and then putting their branded cocktail of minerals in, whether it's Dasani, Aquafina, or any of those companies. That's why their bottled water tastes the same, whether it comes from California or whether it comes from Texas or up in the Northeast. Probably the biggest concern around that is, so for your public tap water, your EPA is doing public water tests every single day, usually multiple times a day, and publishing those results to the public. Whereas the FDA, which is the governing body of your bottled water industry, only does weekly tests, and they have no legal obligation to share their findings with either the public or the EPA. So a lot of more people are taking that environmental and contamination concern and kind of sending it back towards the tap water industry. Just a little idea of kind of the plastic and the energy use going into the environment. So the Pacific Institute in 2006 did a study. They said that in the U.S. alone, the amount of water bottles that we're producing is equivalent to 17 million barrels of oil, which can fuel about 1 million cars for a year, just within our country alone. You're also producing about 2.5 tons of carbon dioxide, and it does take 3 liters of water just to produce a 1 liter bottle of water. So you're going to need a 1/4 liter of feed oil, 2 liters of water, and then of course the liter to fill that bottle. So you're looking at 3 liters and a 1/4 liter of oil just to make every single one bottle of water, which creates a massive ton of waste across the globe. Of course, your ocean pollution. So Ellen MacArthur Foundation estimates that by 2050, the plastic in the world's oceans will weigh more than all of the fish within the world's oceans. This is obviously a forefront on some of the environmental concerns. You see the floating garbage patches and things like that out in the ocean. That floating plastic becomes brittle and takes a very long time to break down. We see about almost 50% of seabirds, 20% of beach animals, and we're starting to see more and more fish that have found with plastic inside of their bodies, microplastics and things like that, which a lot of us are consuming on a regular basis. So the bottles that actually do end up in the landfill. So about 80% of plastic bottles sold end up in landfills to basically sit there perpetually. They're overflowing with about 2 million tons of waste sitting in these. It can take about 1,000 years for a single plastic bottle to decompose in these types of situations, as well as they're leaking those harmful chemicals back into the environment, back into the air, and things like that. Which kind of gets us to where we've been, kind of guiding towards, which is that need for bottle refilling stations, bottle fountains. It is a safe, it's effective, it's fast, easy and way to install, and just nice, simple way to obtain drinking water. Whether you're there for a quick drink and on with your day, or whether you're looking to fill up your 64-ounce canteen that I see many people carrying today, as water has become the most popular drink in all of North America, beating.
Bob, I think you got a second audio connection there.
I have no idea why that is.
I don't know if you're in as that's wild though. Unfortunately, I'm unable to mute it.
Okay.
No worries. We'll just keep trucking. It's all good.
Yeah.
So according to the EPA, the cost to treat, filter, and deliver tap water is about 2 cents a gallon, which is anywhere from $7.50 to almost 3,000 times less expensive to buy bottled water. And given that Americans drink about 36 gallons of bottled water a year, that number has actually gone up to closer to about 48 gallons of bottled water a year. The large volume of that plastic is definitely not being recycled, and it's ending up kind of in those waste systems. So a lot of cities today are responsible for collecting, transporting, dealing with that recycling, which has huge costs to it. Even if those bottles are recycled, there is a huge, massive cost to moving them around and actually getting them properly recycled. So the movement to reusable bottles has been huge in a lot of different cities. So we'll talk about a few of those. So Concord, Massachusetts stopped the sale of any non-sparkling, unflavored drinking water. So things like Propel could still be sold by Gatorade and those types of guys. But any single-use plastic bottled water of any 1 liter or less became one of the first actual towns to ban it. And then now we've got things like the Sacramento government. Anything that's a government-owned building no longer can buy single-use plastics. There is a ban the bottle campaign that you can look up online, which is a variety of colleges that have banned single-use plastics, and a ton of other cities across the country have started to do the same. New York City, Washington, D.C., all ways to encourage their residents to drink their tap water, reuse their bottles, get things like stainless canteens, which are recyclable a lot easier than plastic at the end of their life cycle. Just a whole lot more of an environmental look at the bottled water industry there. This is just kind of just a simple case study where people were having a ton of plastic cup usage and waste. So they installed these, which brought along, a lot more of people using their reusable bottles. So for specifying commercial water delivery systems, some of the things to keep in mind, first and foremost is your material. So drinking fountains, coolers, bottle fillers have a ton of different variety. Obviously, as you can see here on some of the older images on the right, you've got your cast iron and brass construction that are still very commonly used in outdoor applications, as well as stainless steel, which has become very popular in more of the more common modern looking units and your more tubular style units. Really, when it comes to stainless steel, the main thing to think about is the grade. So anything on your indoor style use, we're always going to recommend a 304 grade stainless steel. Will hold up for anywhere from 50 to 70 years on indoor use. And anything on your coastline, beach environments, anything with high corrosion. I'm from Chicago, so for anything that's going to be dealing with a lot of salt being thrown on it in the winter, you're going to go with your 316 grade stainless steel. A little bit more corrosive resistant. We'll be able to stay up to things like beach environments and chlorine a whole lot longer before you're starting to see any type of patina or anything like that on the unit. A couple other things to keep in mind. Things like stainless steel and brass do not require an antimicrobial additive with their already naturally antimicrobial properties similar to copper. But a couple things like anything that has any plastic, your mouth guards, your push buttons, any of your recessed valves, things like that, you're always going to want to be done with an antimicrobial plastic or have antimicrobial properties molded into that. And of course, always try to keep vandalism in mind on how frequently this unit's going to be used. On outdoor things like parks, heavy duty cast iron, heavy duty stainless steel is always a great option. On materials inside, it's always great to maybe switch out those plastic bubblers or those antimicrobial bubblers and plastic push buttons for something that's more brass or stainless steel construction. And then, of course, if you're going to do anything freeze resistant on your drinking fountains, they just want to make sure that that valve's buried properly. So you're going to have to take in that frost line into consideration. That way, these guys out in parks and places like that don't have to winterize their units. Your refrigeration versus your non-refrigeration. Really in climates that can go up and down, you're never really going to want to put one of those style units there on the bottom right outside. You're going to want to go to something a little bit more rigid and able to handle those types of temperatures, as well as being able to put that valve, that chiller, and all of that assembly into that temperature controlled environment behind that brick wall. On your non-refrigerated units, this could be very popular in areas where they have, a hard time getting power out to those units. That way, all you really need is that water pressure and that waistline to be able to provide that nice, clean drink of water through the filter, which we're talking about here next. So your filtration, all filter cartridges are going to have a specific lifespan depending on how many gallons have flown through that. Very common in the industry is around 1,500 gallons to 3,000 gallons, gives you about 6 to 12 months of usage. It's very, very important that these are changed out regularly. You don't want those contaminants sitting stagnant longer than the filter lifespan is designed to be used, as well as, once it has filled up all of its membranes and materials and everything else inside of that, it's no longer going to be filtering at the quality that it's designed to, as well as certified to. Always look for filtration with NSF certifications for your chlorine, taste, odor, and lead removal. Usually down to a 0.5 or a 1 micron is most common in our industry. Just a couple good options for your vandal resistance that we talked about there a couple slides ago. You've kind of got your good, better, best in the industry. You've got your standard unit on the left, the unit in the middle, which has gone to a full stainless construction. And then we've got your 14 gauge all the way to the right, which can handle baseball bats and anything else that someone wants to try to throw at it. Ease of installation. I know Rob had spoken about this before. We'll talk about a few things here. Your ease of installation and your low maintenance costs is something that's incredibly important in the industry today. Guys don't want to be constantly wrenching on these products that are specified. Ideally, the goal is to put these on the wall, have it on the wall, and basically have to do very minimum maintenance on these. So it's always nice to be, have those options to do value engineered solutions for some of these things, but it's always nice to have something that installs quickly and can be easily maintained. Obviously, as you can see there by the product on the right, some products have a whole lot more difficulty to be able to get in and access that P-trap, that water inlet valve, clean out the regulator. And then some of the manufacturers in the industry have just created a few different things that make this a whole lot easier to get into, whether it's a multi-tool key to access a lot of the main features, whether that be a water shutoff supply so the guy doesn't have to get into the water inlet supply, or to be able to get to that P-trap and unclog it, or anything else that needs to be done in the drain line. A lot of preventative maintenance needs to be done on these coolers, and if it is done properly and regularly, you will have a product that lasts 10 to 20 years very easily. Standard interchangeable parts has become very important with these. Some manufacturers do a lot of privatized and only through them type of products, where other manufacturers are using certified NSF regulators, certified valves that a lot of the different other cooler manufacturers are using. So a lot of these parts can be interchangeable, and also that you're going to be able to repair these coolers for a long time without having any proprietary pieces go obsolete or something like that, causing you to buy an entirely new unit. Another feature to look at is either your touchless, your sensor activation, or your traditional push button. COVID brought along a lot of fully, sensor operated units where not just the bottle filler is operated by a solenoid valve that's electrically activated, but also the actual cooler itself. So that cooler can be activated when you walk up to it without having to touch anything at all to be provided with a drink, just giving you that true 100% hands-free operation. Few other key features that we'd want to go through. Obviously, your bubbler, your main thing to look at is your low GPMs with your flow restriction, ADA compliance, as well as your antimicrobials. Probably the biggest thing that I'd like to talk about here is how your evaporator tank works. It's probably one of the biggest differences in the water cooler industry between manufacturers. So your evaporator coil that you can see there at the bottom image left there, there's really two different types of ways that the industry is using these. Kind of the older way to do things is that unit X, kind of like a tank type water heater. So you've got one of those coils running independent R134A refrigerant through it. The other coil on the inside is just running the water that is eventually going to be consumed, obviously independent, non-contaminated water lines. And that cold transfer from the refrigerant to the water is what's going to bring that temperature down to the 55-degree delivery that is specified for these products. That said, in some of the older means, once that it goes around that coil and that water is chilled, it's distributed into about a half-gallon reservoir that sits on the inside of that coil to remain cold. The issue is in times of things like summer in a school district, you've got that water sitting for about 3 to 6 months at any time. You start to get that standing stagnant water, which creates bacterial concern, Legionella concern, as well as just those contaminants settling in the bottom of that reservoir and then being distributed off through the product if it is not filtered, especially. As well as, that fourth or fifth person using that product, that tank has been depleted and they're now getting ambient temperature water. Some of the newer ways to do it that some manufacturers are using are they're using a little bit of a larger diameter coil, and that's acting as that tank. That way the unit acts more as like a tankless water heater where it's providing that chilled water a whole lot longer. It doesn't have that standing stagnant water in the tank. And most manufacturers are using these coils and making them out of copper, which has antimicrobial properties traditionally, which gives it a whole lot more of a safer as well as a more efficient way to do the evaporator coil on the product. Excuse me. Just a couple other accessories that are available for these, access panels to be able to get to the in-wall units, freeze resistant valves, which we talked about a little bit. So these units don't need to be winterized and will operate in cold weather conditions. Hose bibs, jug fillers, any types of louvered grills to provide ventilation, mounting frames that can be put in the wall before installation on new construction jobs just to make it a little bit easier. We can do a variety of international compressors at the 220 volt, 50 hertz, sensor operations, any type of ADA cane aprons, your usual traditional accessories that are common on all manufacturers here.
Just actually had a quick question, circling back to that evaporator you're talking about for the chiller. The one thing that I guess would remain the same in the spec is it's still looking at that 8 gallons per hour. Is that still the standard that it's doing so?
Yes, that is true. The 8 gallons an hour standard still remains the same. The verbiage of temperature of inlet and ambient air and water delivered will still remain the same. It's just a matter of efficiency on how long it can deliver that temperature, as well as a matter of the safety and bacterial concern with just not having that standing stagnant tank. Just depends on which manufacturer does it which way.
Also, kind of how quickly the system can recover too, right? Like
absolutely.
Tankless system, it recharges so fast compared to a vessel of water you're trying to get back to temperature. So.
Yep, and I can see if I can find the Delta T graph. Basically, units without the tank are able to hold that 55 to 60 degree delivery water temperature for about 10 to 15 minutes, where the tank type unit is coming into ambient inlet temperature of the water supply, depending on where you are in the country, within about 3 minutes. Last couple of things, just some tips for choosing those right fountains. First and foremost is, location. Is there going to be people walking by, riding bicycles? If so, maybe the pedestal mount that you'd see here might not be the best direction. You might want to go with something up off the ground to prevent somebody from hitting that. On anything that's installed outdoors, you're usually going to want to do something with a little bit of a stronger construction, whether that be brass or 316 stainless steel. And if those temperatures dip below freezing, you're definitely going to want to install either that frost resistant valve, or make sure that the person maintaining that unit is actually going to go and shut off the water supply and drain out that unit every year when they winterize everything else in the city. Vandal resistance is a huge thing. How abused is that unit going to be? How out in the public is it going to be? And then, of course, who's going to benefit it? Is it going to be someone with ADA concerns? Or is it going to be near a pet facility? Is there going to be a ton of people coming by on a running track and you want multiple arms so multiple people can use the product simultaneously? There's all sorts of things that can go into these products, and that's where we become, very diverse with our product portfolios within the industry on both your outdoor and your indoor units. We can do a lot of variations, modifications, adjustments for almost no cost, just to make sure that we're servicing the market and servicing the designs that you guys are creating day in and day out. So with that, we're just about wrapped up. Kind of buzz through the resources. If anybody would like to see where a lot of this information came from, I'm happy to send over this presentation. Again, my name is Mitch Whittington. I'm with Murdock Manufacturing, been around since 1853 in the water cooler, drinking fountain, and hydrant space. If anybody has any questions, I'll gladly put my information in the chat. I've been in the water cooler industry for about 8 years now. So as you could tell, I'm a little bit newer to some of the biggest histories and certifications, everything like that. But when it comes to product installation and that type of stuff, I'm very well versed, and please use me as a resource.
Yeah, I mean, you're young and experienced compared to the, 175 years that the company has overall, but that was fantastic. Clearly a lot of information that you're able to cover. And I think the list of all the resources there shows how in-depth the research is on this. I'll actually take over the screen sharing here real quick as we wait for the questions and everything coming in. And I did actually have a question for Rob really quick as I switch over. You touched on the winterization there at the end. And I wondered whether or not that is similar for Canada, or do you see more of a shut-off method going on?
I personally see more of a shut-off method happening. Like we're typically always winterizing the parks and stuff up here as it is. So it may not always be worthwhile the extra expense of digging the pit and burying the freeze valve. Well, yes, technically the valve is going to operate all year round because all the water drains below the frost line. You still have challenges with respects to surface moisture on the outlet, instantly freezing over. Same thing with your strainer. And let's face it, like, how often are you walking through a park having a drink in the middle of February in Canada? Not that often. So I personally feel like the freeze resistant is almost giving us like an extended shoulder season. So you're not maybe having to winterize right at Thanksgiving. You could go, a little later in the season. But for the most part, I feel like most parks and recs are winterizing as it is. So like, I feel standard is the better choice. Certainly freeze resistant will work, and it's still great, but for sustained deep below zero temperatures, we're not really drinking outside anyways. So
I think it's good to know that it's available there if you wanted it. As I think people online can probably see here, I've switched over to our ATS spec system. If you just go to atspec.com, I'm sure many people on the call have probably seen this part of our ATS University before, but I'd like to show where you can find the products that we discussed today. If you don't have your login, let me know and I can get you set up on the system. As you see, I'm on our dashboard here where we've got our quick specs, where all you need to do is put in a simple spec name. We've got our projects where you can put in your location data, select your application to make sure that we're giving you that good, better, best type package based on your product selection or based on your application selection. And then of course our masters, which I'll touch on a little bit more detail after I hop over to the project area. I've already set up our hydration webinar demo project here just because I'm always anticipating being a little short on time. Not that there's just a lot of great product info to go over. So if you wanted to add a drinking fountain into this product, we can hit add drawing, and you can see we've got the wide variety of product categories that are available here. And one of the comments that we were getting early on is, well, how do I go about finding the actual product that I want. So we added the find categories search field here, as well as this little pin option. So if we're frequently specifying our drinking fountains, I can pin this and it will put this right to the top. You can see some of the other products I've pinned, like my pumps. Now, if I wanted to make sure I had the right PRV selected, as we mentioned, that's important to have the right pressure and not getting spikes to mess with the valves. But I'll jump into our drinking fountain category here. And you can see we've got all the different filters that'll help us find the products. There's 58 of the various Murdock products listed on the system currently, with our most specified series here. So you have the default view, as well as our most specified series view here. So you can see that barrier-free bi-level is the most commonly selected product so far. You've got your options that you can configure along the way, and this will make sure that you have a fully configured, customized model number to add to your product specification package. If I wanted to filter down, I can go into making sure that all the options I'm reviewing have a bottle filler included. And again, see the various options that are available here. So we'll go through and add our bi-level here really quick. I'll configure this with a sensor operated bottle filler. We'll select that low flow flexible bubbler, the standard gray finish cooler, but I could select that satin stainless finish. And then, we talked about the filtration. We didn't really cover the features of the drop down door, but if you want to cover that in a future session, reach out to me and I can have Rob and the Dobbins team join me for an in-person lunch and learn or virtual lunch and learn for your specific firm. So I can add that to drawing now. You'll also see if I want to review more detail, I can hit view spec sheet and the manufacturer spec sheet will pop open right within my browser. So you can confirm all the various options and flow rate details, installation drawings, all that information, all within the spec tool system. I'll add that to the drawing. And then as with the rest of the spec tool, we make sure you have all the compatible components to make a full complete system. So we would give you your stop valves, trap, carrier options, or you can simply hit complete and finalize the selection. Now I wanted to show one of the other features, which I think often gets kind of overlooked. We did recently launch our templates, which is essentially the ATS version of a master, but you could also set up your firm specific versions of a master. So essentially this could be, whatever your firm name is, bottle fillers, and it would be the standard bottle fillers that align with your internal written master or internal standards, your internal frequently used products, whatever it is you want to call them. And you can see we've got all the various products that I was just showing, including that barrier-free version. And I put a handful of products in here that I thought might be interesting to look at. The recessed bottle filler only with chiller, the same version that we saw on the site, more of that bird bath design. And again, you can get your Revit for this specific file or the specs for this specific file right from the edit drawing page here. So if you want that higher end looking finish, you can see it there. Comes with a bottle filler option. And of course, as I mentioned, all the various components, including carrier, that you might need to actually install the product and issue a complete specification. Once I hit select all, I can go to my copy to button, find that project that I had set up earlier. You could also copy it to a individual spec, that quick spec that I talked about before, or if you're building another master, maybe you want to set up your educational master, or a particular owner group that you're working for has a certain standard that they like to see. And you can see it copies over. Here's the difference between the two. The incomplete spec that I had done before, I'll delete that because I hadn't gone through and selected all the other components that I need. And of course, if you need to edit anything, you can change the tags. But once you're happy, hit download and download it in one of the 10 or so different formats that we have available. I've gone through and pre-downloaded some of the formats, but I'll walk through the submittal. We have a product brochure, schedule, various written specs, the manufacturer specs, which a lot of engineers I'm finding are switching to just putting the actual manufacturer spec sheet right on the drawings. So that's available here. Revit for the entire package, or a CSI 3-part spec. I'll download the schedule really quick just to show it off. But like I mentioned, I pre-downloaded a handful of these file types ahead of time, because again, I'm always expecting to be running a little bit late, which I see it's already just after 1. So I'll just skip over, show you this middle page. Our manufacturer spec sheet package with the table of contents, small numbers for all the products that were included, and the manufacturer spec sheets. And then of course our product brochure puts more of the visual image and just the critical details and information that you would need for the product. So this is great for like your budget review meetings, anything like that. Over to our written spec, which you can include the formatting or not include the formatting, up to you. Gives you them all the information. You can then copy and paste this into your internal written spec as needed. So easy to use. If you want more information on the system, if you want a reminder of how the system works in a little bit more detail, feel free to reach out to me or my market development team, Mo, Natalia, Melanie across Canada, and our US team as well. We'll be happy to do a one-on-one demo. Otherwise, I want to thank you very much for your time here today, Mitch. This was fantastic. I know we had a lot of detail covered there. We will take a pause here as well, just to let those that joined us dip off and get on with their day. But for anyone that has additional questions, we'll stick around for a couple of minutes to see if there is. A very quick thank you again for our attendees. Hope you got a lot of value from the conversation today. And we'll be sending out the certificate of attendance probably tomorrow. Thanks again. Have a great rest of the day.
Thanks, everybody.
Thank you very much, everyone.